Context-aware agents, enhancing security in a zero-trust environment. Introduction. In modern organizations, security is paramount. Employees are often provided with company-issued, highly credentialed devices to perform their work tasks. However, with the increasing overlap between professional and personal life, employees may also wish to access corporate resources like email and calendars on personal devices. This creates a security challenge, as different devices have varying levels of trustworthiness and risk. To address this, security teams implement fine-grained access policies based on the context of the request. For example, it may be permissible for an employee to commit code from their company-issued laptop but not from their mobile phone, as mobile access to source code presents a higher security risk. However, accessing corporate email from a personal device may be allowed. This principle forms the core of context-aware security in a zero-trust environment. The role of context in security decisions. Zero-trust security models operate on the principle of continuous verification rather than assuming trust based on prior authentication. This means that multiple factors influence access control decisions, including the identity of the user, the device being used, the location and network conditions, the type of resource being accessed, the security posture of the requesting device. One of the key innovations in zero-trust security is the introduction of context-aware agents, which facilitate policy-driven access control by dynamically assessing these factors. What is a context-aware agent? A context-aware agent is a security construct that represents the combination of a user, device, and application in a request. Unlike traditional security models that authorize these entities separately, zero-trust models evaluate access requests holistically by assessing the context as a whole. Key characteristics of an agent. 1. Dynamic nature. Agents are ephemeral entities formed on demand for each request. 2. Real-time assessment. They continuously evaluate changing security conditions. 3. Granular control. Policies can be fine-tuned based on the agent's properties. 4. Risk mitigation. Helps minimize risks related to credential theft by considering multiple authentication factors. Components of an agent. Agents are composed of various data points that describe the user, device, and session. These include user attributes, identity, username, email, role, group memberships, authentication method, password, MFA, biometrics, trust score based on user behavior, device attributes, device ID and type, operating system and version, hardware security e.g., Trusted Platform Module TPM, patch status, device trust score, session attributes, IP address and geolocation, time of access, application or resource being requested, network security posture, e.g., VPN, public Wi-Fi, corporate network. How agents influence authorization. Since an agent encapsulates the entire context of an access request, policy enforcement becomes more precise and adaptive. Here's how agents drive security decisions. 1. Conditional access control. Example: a user attempting to access a confidential document from an untrusted device might be required to complete an additional MFA step. 2. Behavioral risk assessment. Example: if a user's behavior deviates from their usual patterns, e.g., logging in From an unusual location, the system may flag the session for further review. 3. Real-time trust adjustments. Example: if a device's security posture deteriorates, e.g., OS is outdated or missing patches, access may be downgraded or revoked. Agent volatility. Handling dynamic security data. Because agents rely on real-time data, they must account for rapid changes in security conditions. For example, trust scores fluctuate based on ongoing risk assessments. Device status changes, such as being unenrolled or compromised. Bootstrapping scenarios, where a device is in the process of registration and lacks full security validation. Standardizing agents for consistency. Currently, there is no universal standard for defining agents in zero-trust frameworks. However, adopting structured data formats can improve interoperability and scalability. Possible standardization approaches. Using JSON Web Tokens, JWTs, to encode agent data securely. Leveraging SNMP-like object identifiers, OIDs, to define agent attributes. Integrating with existing authentication protocols, such as OAuth and SAML. Example: JSON representation of an agento securing agent data. Since agents contain sensitive information, their data must be protected. Key considerations include encryption, secure storage and transmission of agent attributes, access control, restricting exposure of agent data to authorized systems only, data minimization, avoiding excessive collection of user details to preserve privacy. Future trends in context-aware security. As cybersecurity threats evolve, context-aware security will play an increasingly vital role in organizational defenses. The future of context-aware agents may include AI-driven decision-making, machine learning models that continuously refine trust, scores based on evolving risk patterns, decentralized identity management, blockchain-based verification mechanisms to enhance agent integrity, automated policy enforcement, integration with security orchestration, automation, and response (SOAR) platforms to enable automated remediation actions. Conclusion: context-aware agents are a cornerstone of zero-trust security, providing dynamic and granular access control based on real-time security assessments. By integrating user, device, and session attributes, organizations can enhance security while maintaining a seamless user experience. Standardizing agent structures and securing their data will be crucial in advancing the adoption of zero-trust architectures in the future.